Hi and welcome to Unit 1 Topic 3 Video 7. And in this video we'll be talking about equivalent statements and a little bit of mathematical logic. So you've seen some of this symbology earlier, and we're going to talk about how we can do some direct proofs but of equivalency rather than those sort of algebraic statements or geometric proofs we've been doing. So statements may be connected by either one may imply another, so we're trying to prove that this implies that, or we're trying to prove that two things are equivalent. So take, for example, P, Q, and R here. And it's all about the algebraic term x, and x exists in the natural numbers. So P is saying that x is greater than 40, Q is saying that x is equal to 57, and R is saying that 2x is greater than 80. So in terms of P and Q, Q implies P. So if Q states x is equal to 57, that implies that P is true because 57 is greater than 40. But P does not imply Q. So if you know that x is greater than 40, it does not mean you know that x equals 57. X could be 54, it could be 61, it could be 500. So there is a Q implies P relationship, but it's not the converse of that. It doesn't reverse. Now, 2 is P equals, and P and R. So P and R, and I'm making a statement here, P is equivalent to R. Now let's have a look. If x is greater than 40, well then 2x is greater than 80 is an equivalent statement. It's an unsimplified statement of P, really. So we can prove that by showing that P implies Q. So if x is greater than 40 and we show that 2x is greater than 80, bit of algebra, and that P implies R, my apologies, and that R implies P, its converse, then they are equivalent statements. So my next question is, what about Q and R here? Now, this is hopefully it's fairly easy. It's a lot like 1. Again, Q implies R. I'll do this in purple. Q implies R, but R does not imply Q. So if you know R to be true, it does not mean that Q is true. So that's where we're at with that one. So let's talk about proving equivalencies. Remember, if and only if is IFF. And a little note there in pink, if we're doing some work in a proof situation that's not algebraic or not that sort of step-by-step geometric, then we should be considering using these equivalency or implied signs to move from step to step. So this implies this, implies this, implies this, and therefore proven, rather than equals. So P is equivalent to R if P if and only if R is true, and R if and only if P is true. And so you know this if and only if creates that equivalent statement. So let's have a look at example 7. There's an A and a B, and probably one's going to work and one's not going to, because it's asking if they're equivalent statements. So what we're going to do is show that P implies Q, show that Q implies P, and then conclude. So we'll start with A. In A, X and Y are rational is P, and we want to show, does P imply Q? So let's have a look at this. If X and Y are rational, then P is X equals A over B, and Y equals C over D. They're rational where A, B, C, and D are integers. That's the proof. That is the definition of rational numbers. So X plus Y, which is our Q statement, is X plus Y is equal to A over B plus C over D. Now it's okay to use equals here because we're not working on an implied statement. A over B plus C over D is AD over BD plus CB over DB, and now I've got the same denominator, and I get AD plus CB over BD. Now in this case, I know that AD plus CB and BD also exist in integers. That's pretty clear, and therefore this is also rational. So P does indeed imply Q. But what about does Q imply P? Now this one's a little bit trickier because we can say, so I'll write the statement down here. Does Q imply P? We can say, well, Q is equal to X plus Y, and that is rational. That's the statement. So therefore, X plus Y is equal to A over B. Now what I'm actually going to do here is I'm going to prove this by counterexample. Is a good way of doing it. So here's an easy one. And so you've got to think a little bit more widely about some of these questions. Well, what if X is equal to 1 plus root 5? We all agree that root 5 is irrational. And Y is equal to 3 minus root 5. So these both do not exist in irrational numbers. But X plus Y is equal to 1 plus root 5 plus 3 minus root 5. They cancel out and it's equal to 4. And 4 is a rational number. So we've shown here a counterexample to say, we'll get to counterexamples a bit later, but to say that since P could contain X and Y that are irrational, but Q could then be rational, well, Q does not imply P, and therefore it's P implies Q only, but they are not equivalent. Which means that probably our second example will be. So let's have a look at that second example now. I suspect I need a little bit more space. So this is part B. In part B, we're told that P is X cubed is greater than 0, and Q is the statement that X is greater than 0. So I'm going to start with, does P imply Q? Does P imply Q? And I think this one's probably the slightly harder one, but not too bad. Let's go with X cubed is greater than 0. Then we get the cube root of, so it's going to equal some A, some positive value. So X cubed equals A, where A is a real number but positive. So there's nothing about rationals here, just a real number. And therefore, X is equal to the cube root of A. And because A is positive, we know that when you cube root a value that's positive, there should be a 3 there, well, it has to be positive as well. If you cube a negative value, you get a negative. So this is positive, and therefore X is greater than 0 as well. And so P does indeed imply Q. And of course, we get the converse of this as well. So does Q imply P? Well, the answer is we know, we're assuming that X is greater than 0, and therefore X cubed, for the same reason, will also be greater than 0, because when you cube a value, if it's positive, it remains positive. If it's negative, then it becomes negative. And so therefore, we get the statement P and Q are equivalent. Now, you could break this down into a little bit more detail, but I think this is fairly conclusive. It's a fairly simple problem to go through, and we've proven that P and Q are equivalent. All the best.